Let us look at some questions. Number 1 asks, from the list below or alongside, select the unsaturated hydrocarbons. You're given an alkane, an alkene, an alcohol, and an alkyne. Of course, the unsaturated carbon will have double bonds or triple bonds between its carbon atoms, and those would be an alkene and an alkyne. An alkane, as you know, cannot be unsaturated because it has only single bonds between its carbons, and an alcohol contains another group on the carbon chain, which we haven't looked at yet, more on this later, but it does not consist of only carbons and hydrogens, and so it cannot be a hydrocarbon. The second question asks you to classify the following as organic or inorganic compounds. You've got paraffin, baking soda, and lighter fluid. Well, we have seen that paraffin is the substance which makes up candles, and that is a hydrocarbon. So that would be an organic compound, paraffin. Baking soda is just bicarbonate of soda, so it is NaHCO3. Although it contains carbon and maybe a hydrogen not attached to that carbon, but attached somewhere else, it is not an organic compound, so it is an inorganic compound. Lighter fluid is, of course, butane, and that is a hydrocarbon, so this would be an organic substance. Third question asks, what is the difference in structure between alkanes, alkenes, and alkynes? Now, the difference in structure is that alkanes contain single carbon-carbon bonds, while alkenes contain at least one double-bonded carbon-carbon bond, and alkynes contain at least one triple-bonded carbon-carbon bond. Or we can say that alkanes contain only single bonds between carbons, while alkenes and alkynes contain double and triple bonds, respectively, between their carbons. What is the test for saturation? Write 2 chemical reactions to explain this test. Of course, the test for saturation, as we have said, is the bromine test, where you add bromine water to your 2 unknown substances. If it reacts really quickly and it discolors really quickly, we know that is an unsaturated compound containing double bonds. But if it does not discolor at all or take a very long time to discolor, we know that is a saturated compound because it only contains a single bond between carbon atoms. A chemical reaction would look like this. If we first look at a saturated compound, it would contain only single bonds between the carbons. And the simplest we can take here would be something like this, right? With at least 2 carbons to show that single bond. And now we've got bromine, 2 bromine atoms because it's diatomic. That will form over a long period of time, eventually something looking like this. These are my hydrogens, and a bromine atom will attach itself onto one of the 2 carbons, and then the hydrogen that came off of that carbon will now bond to the remaining, bromine, and it will form also HBr. But if you have a double bond, I'm just going to clear all of this. This is what it will look like. If you have a double bond between carbons, 2 hydrogens respectively bonded to the carbons, because carbon can make only 4 bonds to other substances. I add my bromine water to it, it will look like this, BR. And now, as we said, this weak pi bond, the first bond is a very strong sigma bond. The second in that double bond is a weak pi bond. And so when it reacts with another substance, that weak pi bond will break, and you can visualize it as a double gate opening, and then you have the 2 bromine atoms adding itself onto the chain like this. You now only have the sigma bond left between the two carbons, and you can put a bromine up here, and the two hydrogens that were there before, the other bromine will come and sit down here, and the two other hydrogens that were there will shift into these positions. Please take note, because bromine is quite a bulky atom, that it will take up a lot of space, and you cannot draw the two bromines sitting right next to each other. They will sterically hinder each other, meaning spatially, they will hinder each other and repel each other. So they will instead move like this to attach like this at the top and at the bottom, above and below the molecule, giving you this as the product. So this reaction takes place very quickly. If we add a little bit of heat and light we write as HF, right? And you add a little bit of light and a bit of heat to this reaction to make it happen. It will go from brown to colorless. And this is the test for saturation. Thank you for watching.